the Medical AI Podcast.
Welcome to the Medical AI Podcast with me, Dr. Felix Beecher. Strap in for a 30-minute thrill ride of big ideas. Radiology could be the most important area of medical AI. It has the most FDA approvals, with almost 1,000 by the FDA since 2017. So radiology is undergoing a major AI transformation. But the abundance of radiology AI tools has created a big problem. With so many options to choose from, healthcare providers are often confused about which tools to deploy, how to deploy them, and how they will work. This uncertainty is a significant brake on progress, and part of the solution may be that of AI marketplaces or platforms. Well, what are these, and what are the lessons for other areas of medical AI? With me to discuss this very important area is Pelu Tran, CEO of Ferrum Health. Pelu, a very, very warm welcome to the podcast. Could you please introduce yourself to the listeners and explain a little bit about your background?
Hey there, Felix. Thanks so much for having me on. As you mentioned, my name is Pelu Tran. I'm the CEO of Ferrum Health, and we have been helping health systems and AI developers serve their patients and clinicians for the past 6+ years. My own background, I was originally an engineer and attended Stanford Medical School. I was applying into radiology residency when I had the opportunity to start a company back in 2012 and built and scaled that company, ultimately bringing it public. Ferrum Health I founded in 2018 because of a personal experience I had where a close family member of mine, my uncle, passed away from a missed lung cancer. And I remember sitting here in the heart of Silicon Valley and knowing many founders that were trying to improve quality of care for lung cancers, breast cancers, other diseases that had painfully gotten their FDA clearances, were out there on the market trying to sell them, but for many reasons just could not get their products into the hands of doctors and patients. And when we saw that AI was going to continue to expand and accelerate and become more powerful, we realized that there needed to be a better way to get these AI tools in the hands of those who need it. And that's why we started Ferrum Health.
Now, back then, AI platforms were probably not really very much known at all. Is that correct?
That's right. I think most people were thinking about AI in the context of point solutions. They were saying, do I deploy stroke or do I deploy lung nodule or breast lesion detection? But the broader question of how do we actually effectively keep up with the pace of AI innovation is a second order one, and one that has really come to the spotlight in recent years.
So how did you have the foresight, Pelu, to look into the future and see the need for AI platforms when generally people were not?
Well, I think that the challenge of technology adoption in healthcare is something that you're familiar with, but everyone understands. The average health system spends hundreds of thousands of dollars for every vendor they onboard. I remember there was one stat out of one of our customers where they were spending $500,000 to $700,000 on internal costs just to turn on a $50,000 solution. And that was the number that when we were talking to our friends who were the IT leaders at these hospitals, I was just flabbergasted by, because how could you be spending 10 times as much on your internal costs to deploy an AI tool? And how could that be how we're going to transform and improve patient care? So it was that financial disconnect of it being so expensive to turn these tools on, there being so many of them, and frankly, every single year, even then, hospitals falling further and further behind on delivering the tools that their doctors want. And every doctor you talk to is going to have the same viewpoint, where they're just frustrated with how slow it is taking to get their IT tools deployed and how they aren't able to actually use the tools they want. I think if this were pharma or med tech and doctors were this far behind on technology adoption, there would be an uproar. But in AI, I feel like that's just beginning.
Well, I guess because it's a new field and people don't really have very solidified expectations about how things should work. Is that true?
Totally. There's a bit of a self-induced harm here where a lot of technology companies come into this with a very technological mindset of we're going to replace the doctors, we're going to disrupt healthcare. And I think
Yeah.
that mindset has been pretty harmful for getting acceptance and getting excitement. But as you know, AI is on the tips of everyone's tongues, and
Yes.
we're very much in an era where it's a necessity, not a nice to have or a threat.
Now, lots of listeners may not have even heard of radiology AI platforms. So, could you just begin by describing what they are, how they work, and defining what they precisely are for?
Of course. So AI to date, and the AI that most of us use, are tools that are hosted in the cloud. And if a provider wants to use an AI tool, they need to send that patient record to that cloud provider, to that third-party vendor, and then receive the results back. And that works for one or two AI solutions. If you're just sending a CT scan to a third-party vendor for lung cancer screening to find lung nodules, that's great. The challenge arises when you have more and more AI tools that you want to deploy on the same patient population. So instead of just wanting lung nodules, maybe you also want to look for aortic aneurysms and pneumothorax and fractures and cardiomegaly and all these other diagnoses, right? The average imaging study has hundreds of diagnoses that need to be made on it. And the average AI solution finds one of them. So as hospitals started to think about using more AI, they realized that they were going to have to send copies of every patient record to every vendor they wanted to work with. They were going to have to deal with the security knock-on effects of that. They were going to have to deal with the complexity and the network load of all of that cloud integration and upload and download. And they were going to have to figure out how to manage those AI tools for themselves to maintain patient safety and to make sure that they're actually being deployed and utilized in a reliable and safe manner. And all of those risks and threats are things that don't really come to the forefront until you start to really think about what the future looks like. And so AI platforms are the natural response to this market fragmentation, the cybersecurity risks, and the challenges with performance for this old method of AI adoption, this kind of point-to-point model. And platforms serve as aggregators. They serve as single interfaces, integrations, and hosts for a broadening range of AI tools, and they enable hospitals to have, one throat to choke, quote, so to speak, for their AI initiatives.
Well, I suppose that puts the boss of an AI platform in a kind of custodial position in the sense that you have a bird's eye view of the field that providers of point solutions might not. You can see problems because you're seeing them in lots of different point solutions taken together. Is that true?
Absolutely. And this is an issue that has become a real pain point for providers and for regulators because AI tools are not like drugs or medical devices where you can run a clinical trial, get a result, and generally understand that that tool is going to work consistently going forward. Right? Like a hip replacement isn't going to magically stop working just because it's 3 years later. An AI tool, with how patient data, patient populations drift, with how different populations have different demographics, ethnicities, genders, ages, etc., AI tools are wildly different in performance between different populations and very, very often underperform what their FDA clearance was. And so those issues are things that regulators across FDA, CMS, uh, um, and other organizations are really trying to tackle, and that hospitals are becoming aware of as well. A great example of this poor generalizability of AI tools is in breast imaging, where many tools are trained on certain populations in Massachusetts, New York, California, these so-called innovation hubs. And those populations that those AI tools are trained on are very, very different from the populations in the rest of the US or even the rest of the world, where you may not have as many patients of a certain ethnicity, or you may not have as modern imaging modalities and equipment as a Stanford or a Harvard MGB might have. And so all of those things lead these AI tools to really oftentimes underperform, and that creates challenges both in terms of already underrepresented minorities getting even worse care, kind of broadening the care divide, but then also just in terms of fundamental risk liability to the provider if they aren't tracking these tools
Yeah.
and they don't have a partner that isn't the vendor to actually help them figure that out.
So this problem of generalizability seems to be a conversation that is increasing in frequency. And I suppose that is an inevitable consequence of the fact that radiology AI is, even though it's a very small number of years old, is nonetheless in some sense maturing. Do you think that's true?
Yeah, absolutely. And I think that the AI solutions within radiology are maturing to a point where you have so many tools now that are actually really, really impactful on patient care, right? Like, for example, we should not be missing any lung nodules or breast cancers or aortic aneurysms or coronary artery disease or stroke. We shouldn't be missing any of these diagnoses that have AI tools that can be offered for pennies to find sick patients. Yet, over a third of all lung cancer patients have their lung cancer missed at some point during their care journey. So there's this massive disconnect between the care that we should be receiving as patients and the care that we could be receiving given the powerful technologies that are at hand. And the only reason why there's this gap is because these tools are hard to deploy now. It used to be that these tools were very, very noisy. They had really unreliable performance. They were very slow. And as a result, radiologists were kind of like, yeah, we could improve our sensitivity by 1 or 2%, but it comes at a massive workflow cost. And it comes with a lot of burden and technical management. And I think AI tools have matured to a point where they generally work. And now the question is just how do we deploy them within the limited constraints of hospital IT budgets? And then how do we actually support, validate, and monitor them given the sensitivity of these populations and the diagnoses that they're making? And so those are all things that I think are reasons why platforms and AI governance has come to the forefront recently.
Okay, so this problem of AI drift and generalizability or lack of generalizability, let's think about how regulators are trying to address that. Could you summarize that?
Yeah, so unfortunately, the regulatory paradigm here in the US is very much a point in time. You get your stamp from the FDA and you have kind of marching orders, the right to sell and continue with your product uh, essentially into perpetuity. And again, that's based upon this pharma model where if a drug was proven to work 50 years ago, the human physiology hasn't changed. And so you should be able to trust that drug's working. But imaging modalities, right? CT scanners, MRI machines, X-ray machines, all of these things are being refreshed, they're being updated. And even things as simple as increasing the number of slices in your CT scanner can cause these AI models to perform very, very differently. So regulators are trying to figure out how they can keep up with and regularly revisit how these AI tools are performing, kind of this post-market surveillance approach. But the challenge here is that that's a little bit incompatible with how we've historically managed medical solutions. And so I think that's an area that unfortunately will probably require some amount of governmental slash legislative change to really be able to shift. And until that happens, and who knows when it will, that burden very much falls on the health systems and the doctors that are using these tools to make sure that they're safe. Because guess what? If an AI tool doesn't perform, if it misses something, it's the doctor that's signing that note that's still responsible legally. And that ultimately is, I think, why regulators have been able to avoid addressing this issue up front.
It's a very paradoxical kind of issue, isn't it? Because on the one hand, you've got these systems that work very well, and on the other hand, regulatory systems that are presenting some kind of break. It's and obviously regulators, like anybody else, want to see health systems improve over time, but it's a very odd kind of situation.
Yeah, the actual risk here, I think, is that you kind of have three ways you can address this problem, right? One is kind of what we've done so far, which is know that it exists academically, know that, oh yeah, AI tools don't necessarily perform, but say, listen, my doctors are generally okay with it, so we're just gonna bury our head in the sand and proceed onwards. The other one is to say, wow, like we know that these tools, while being safe, present some risk to us because we don't have an ability to monitor them, and so let's just hold off on using AI for now until someone figures it out. And the last one is the one that obviously we're fans of, which is, hey, these tools are powerful, let's try to use them and fix them. But again, that requires data science capabilities. It requires a level of IT sophistication that most providers don't have. And so that's, I think, the paradoxical part of it is regulators are just as afraid of getting in the way of innovation and the patient improvements that can result from AI as they are of the threats that they pose to worsening care divides and health inequity.
So, when it comes to platform providers, how can they address this specific problem of AI drift?
So step one is just to be tracking how your AI tools work. Right? Most of the time, the average health system, when they turn on an AI solution, they look at the literature, they might talk to a few of their peers that are using the tool, they'll turn it on, and if their providers don't immediately riot, they'll leave it on for the 1 year term that they just signed. And there's no sort of engagement beyond that aside from when it's up for a refresh, they go and check on with their doctors and say, hey, docs, so this AI tool we're about to renew, like, still good? And doctors will say, yeah, it's great. And that's generally okay. You get to avoid the really bad tools, but what you miss is these much more fine-grained issues around AI bias, right? Like if a tool underdiagnoses Black women on mammography and you don't have a large African American population, guess what? Like many of your providers will not notice that drift. So you need to have the data science capabilities to see how models perform across different demographics. And then you need to be able to actually make decisions off of that, either in terms of updating vendors, swapping them out, or deciding to pause an initiative altogether. Thankfully, most solutions work pretty well, but it's that edge case, right? You may decide for a certain patient population or demographic that you don't want a solution on rather than have a solution that works poorly. And so you need the ability not just to validate and monitor these tools over time as they're used, but to actually really, with a fine tooth comb, decide when and how these tools are being used on different populations.
So, this is one fundamental way in which platforms can perform a function in the AI radiology market. But it's not the only way in which platforms can help this sector. Could you talk about some of the other advantages of having these AI radiology platforms?
Yeah, we mentioned it a bit earlier, but one of the big threats to healthcare today, and this is a bigger threat than AI as an opportunity, is cybersecurity. And unfortunately, we live in a world where health systems are under constant attack. And the most common, or one of the most common angles of attack is through the vendors that the hospitals work with. Many of the largest security breaches, including Change earlier this year and others, many of these came from vendor backdoors that ended up causing massive challenges with the providers that were using those vendors. And so hospitals, while they are excited about cloud and the opportunities that cloud provides, they're not super excited to have to work with 1,000 different vendors and
Yeah.
have 1,000 different holes in their firewall where they're sending sensitive patient data out and receiving it back. And I actually don't think that there is any way in today's IT landscape to make sure that that sort of environment is secure. You can ask for high trust, you can ask for penetration tests and audits for all of your vendors, but the reality is that the only safe way to deploy AI scalably is to make sure that the AI is running within compute and within an environment that can inherit all of the security controls that a health system has. And like it or not, that means that these AI vendors are going to have to start thinking about being able to be deployed on platforms that they themselves don't own, right? Compute that's sitting within a hospital's data center or compute that's sitting within a hospital's secured private cloud. All of those are much faster and much safer ways to deploy AI tools than just sending and shipping your data off to an AI vendor. However, much in the same way that hospital systems don't have the data science capabilities to manage and monitor the performance of these tools, they also have no shot at standing up a vendor neutral third party container Kubernetes environment that is able to spin up the models for the vendors they want, feed the right data streams into those models, and reintegrate them back into the user interfaces, and do that for 3, 5, 10, 100 different AI models. Like model orchestration, enterprise platforms, those are all capabilities that, just like the EHR, should not be built in-house by providers. And so if they want the ability to deploy AI tools securely into their own environment and to actually have complete control over the models themselves, make sure that the models aren't inheriting or being retrained on their data without their knowledge, and make sure that patient data isn't flying all over the interwebs to vendors in the UK and France and India and Korea, they need platforms that can provide them with that security and safety. And so I think and so I think that security is a huge concern that, if I were to be honest, is probably an even larger risk to hospital systems, and an even larger reason why they're not using these tools, even beyond the patient safety aspects of these tools not being monitored and occasionally drifting or underperforming.
So we've talked about how the early days of radiology AI generally involved providers of point solutions. Now, obviously, we still have lots of providers of point solutions in the market and providers of multiple point solutions. And then we have a layer of platforms on top of that. Could you sort of summarize the interplay between the platform providers and the point solution vendors? So how do those dynamics feed into each other?
Yeah, you would think that platform providers are a necessary evil to the model developers, but the reality is that if you're an AI model developer, you are a machine learning company. You aren't very good at managing and standing up robust, highly redundant enterprise systems. And you're not very good at maintaining healthcare integrations. And you're not very good at data science around patient demographics and population. So those are all secondary priorities for a model developer whose primary job is, I want to build the best model possible that can help the most patients with the most diseases. And so actually what we find is, when we are the platform, or when any platform is being used to deploy a model developer's containers, the implementation usually ends up going a lot faster, a lot more reliably, and costing a lot less money to both the model developers and the health systems. So platforms are actually a significant cost saving play, as well as an accelerant to AI adoption, and that benefits everybody. So I think our relationships with our AI developers is actually extremely strong. And we find that we're able to deliver a lot more insights and have a lot less customer complaints around, hey, the model's not working, or hey, can you look at this issue with your integration, when we're the ones managing it, because that's our full-time job, right? We are specialists in the integrations, the data feeds, the hosting reliably of these tools, and the monitoring of them. And as a result, like, we tend to do a better job of it than an AI model developer would, or than a hospital would. And this is generally of kind of a trend you see with all platforms, right? Whether it's Plaid in financial services or Shopify, right? Like, Shopify is always going to do a better job than a mom and pop shop at building fintech software. So the same dynamics apply here.
I'd love to think there are some exceptions to that rule. So now, I suppose in a way it's kind of ironic, because one of the big problems that platforms are supposed to solve is the problem of too much choice. However, there are also quite a big range of platform providers. So, are they all the same? What distinguishes them if they're not?
Yeah. So I think the most important considerations to have for a platform provider are dependent upon what the hospital system is currently doing with their IT stack. So you would think that, oh, like, we're going to choose the platform provider that has the largest number of applications because we want the largest marketplace. And unfortunately, the way that the AI landscape works is that you probably want a few key use cases that everyone wants, and you probably want the top vendors in those use cases. So the number of applications, even though that is a very commonly used metric by us and others, actually, we're as guilty of it as anyone else is. But I think the number of applications on a marketplace is a bit of a misleading metric, because guess what? You can have 100 or 300 models on your marketplace, and providers are currently using one or two of them. And in 3 to 5 years, they'll use 5 or 7 of them. And so you don't need more selection than you need high quality selection. And so I think that's the other role of a marketplace, which is to allow for this Amazon 5-star rating, Yelp review style
Yeah.
sharing of feedback between providers. And so if a model doesn't work today, providers generally they'll have to go and say, hey, let me ask my buddy at health system X across the street that I know is using this tool how it works. And the vast majority of the time, for the vast majority of AI tools, there aren't that many data points you can gather. If you're working with a platform, you actually have the ability to look at all the insights from that model from other users of the platform, much in the same way that you can look on Yelp and look at reviews. And so it kind of democratizes
Yeah.
access while also giving more visibility into how these tools are performing at your peer institutions. And that's, I think, also a really powerful accelerant to the market.
Okay. Now, as I said before, you have a somewhat privileged position in the sense that you have a bird's eye view of radiology AI. So could you just unpack for me what your major predictions for the field would be for the next, say, 5-10 years?
Yeah, I think the biggest one, I think, is actually something that is a bit of a contrarian opinion, which is I think that health systems, because of cybersecurity, um, and because of, frankly, the cost of cloud compute for these AI models, I think that there is a trend back towards hospitals owning their own infrastructure, whether that's a cloud that they have stood up within a hyperscaler like Google or Amazon or Microsoft, or whether that's literally data centers that they're owning. And the reason for this is because AI compute is extremely expensive. If you're buying a GPU, that's a one-time cost. And if you own it, you get to use it for years afterwards. If you're renting a GPU from a cloud provider, usually the rental costs for that GPU over the span of 3 or 4 months could have just paid for that GPU and for that compute for you to own. And so you're talking about multiple folds cheaper compute uh, for these very expensive workflows in a industry like healthcare, which has pretty low margins. So I think there are cost benefits to taking your AI private, just as there are security benefits. And so we're seeing model developers really recognize that and say, listen, like we can offer our solution more competitively in price if we offer it via some of these privately hosted platforms and allow the hospital to own the compute. And from a hospital standpoint, they're saying, actually, our IT costs are much lower, and our cybersecurity risk is much lower if we also own it. So I think you're seeing kind of an in-housing of AI infrastructure by providers that obviously for us is fantastic news because that's what we specialize in building. But more broadly, I think it's fantastic news for the market because it means we're going to have much more affordable, safer, and more efficiently deployed AI tools, which ultimately means that more AI tools are going to be able to be used by more patients.
Okay, so I think the reason why you're saying it's a contrarian opinion is because the general view is probably that cloud is going to take over and these kind of local solutions are going to eventually fade away. Is that true?
Yeah, and I think that uh, even that is a bit of a misnomer because I think when we talk about cloud, we usually think about, you know, the cloud that you or I use, which is kind of our iPhone and being used to download multiple apps and interact with all those different vendors. But even with cloud, I think hospitals are standing up their own clouds and they're expecting vendors to go in and work within those clouds rather than send patient data out to different vendors. Um, a great data point here is that the most expensive thing you can do with a cloud is have data leave the cloud, and unfortunately, there's no guarantee that whichever cloud provider a hospital uses, that every vendor they work with is going to use that same cloud. And so hospital systems do not want to be spending the money to have to send CT scans or breast tomo studies out to different vendors because that's an expensive burden for them. And it's much cheaper, yet again, even in the cloud environment, for hospitals to say, hey, vendors, stand your solution up in my cloud so I don't have to pay the egress and ingress costs for you. And also so I don't have to deal with the cybersecurity risks of having all these holes in my firewall. So it's even in the cloud environment, I think taking it private is the right move. And it's a move that we're seeing more and more systems do that are intelligent about kind of their security and cloud costs.
Very interesting, Pelu. So look, next question might be quite a tough one. I don't know. What we have here, if we think about the evolution of clouds over time, is a situation where we started off with the point solutions. Then the point solutions became too numerous and some kind of rationalization was needed. Platforms came along to perform that function. And this would seem to be a fairly fundamental pattern of dynamics that could be applied across all sorts of technology areas. Question is, are there lessons in the evolution of radiology AI platforms for other areas of medical AI?
There are, and I think you're already seeing it. Because if you look at the recent announcements around DeepSeek and the models that they've developed and how they are as performant as OpenAI or Anthropic or the meta models that are out there. DeepSeek is an open source model that can be privately hosted by
Let's just back up.
organizations.
Let's just back up a second, right? Because it is, as we speak, the 30th of January. And when was it? 2, maybe 3 days ago that NVIDIA shares took a spectacular tumble because of the emergence of DeepSeek. Do you just give us a little bit of context, could you?
Yep. So DeepSeek, Chinese company.
By the way, I'm hoping you didn't own shares in NVIDIA for that day or two.
No conflicts to report here.
Do tell.
But DeepSeek is a Chinese company that released an open source model that could be hosted on very respectable compute that was as performant as the top of the line open AI models that are out there. And so what it did was it really accelerated the realization that, listen, like if you want to use AI, you want to use the best AI that's out there, you don't have to actually enter into a soul sharing contract with ChatGPT the way that so many of these vendors out there need you to. Because most vendors that are building in foundational models and LLMs, most vendors are just building these kind of API wrappers on top of these open AI foundation models. But what DeepSeek showed is that you can actually have extremely performant models that can run within your environment, that you can retrain on your own patient data, that you can run securely and privately, that doesn't require you to give your patient's information to a bunch of different people. And so you're seeing, even in the LLM space, it being just the past few quarters, you're seeing a return to privacy with LLMs. Where guess what? If you're a health system now and you're saying, listen, I need a scribing solution, or I need a note-taking solution, or I need a chatbot, I now have a choice, or I will very shortly have a choice to have that chatbot or scribe or reporting system be completely private and hosted within my own data center or my own cloud to be fine-tuned and trained on my patient data and customized to my providers. And it will be every bit as performant as these other vendors that are offering an open API to ChatGPT and needing my data to be shared into it. And I think that given how sensitive patient data is in healthcare, and given the issues that have already arisen with data privacy and the use of data by these foundation models, I don't see LLMs and kind of reporting and conversational AI and all of these categories, I don't see them going the way of the public cloud. I see them also requiring private compute at hospitals that can run these powerful models. And so now you're a health system, you're saying, wow, like not only for my radiology AI tools do I want to have a compute platform that can run them for me within my own cloud or my data center, but now even for these foundational models, I also want to have GPUs in my data center or in my cloud that can run these models for me because it is better, safer, faster, cheaper, and it works just as well as the more public cloud offerings. So it's just an objectively superior deployment mechanism in secure industries like healthcare, like fintech, like defense. And so I see that same trend continuing even for these language models. And that's really the future. That's what everyone's excited about today, right?
And how specifically do you think that they might be implemented within radiology AI platforms?
So I think language models are going to start to go from being used for report summarization and dictation, and I think you're going to start seeing them being used to tend reports, kind of provide an initial prelim uh, for providers, and then ultimately allowing radiologists to go in and say, okay, cool. So I had an AI run on the image and it found the three diseases that were present in the imaging study. And then I had that AI automatically generate the report for me for my radiologist to review. And then I was able to sign off on that study very quickly. I think there's some regulatory challenges there that need to be addressed, but I do think that radiologists over the coming, 3, 5, 7 years, they're going to start becoming more editors of the report rather than dictaphone uh, kind of processors of images. And that's going to lead to a dramatic acceleration, which the industry desperately needs, right? We don't have enough radiologists. The number of slices and images that the average radiologist has to review has increased 10, 15 fold over the past decade and a half. It's getting more and more complex. You have the boomer generation retiring. Like we cannot keep up with the amount of imaging that's coming through, and the complexity that it contains. So I think the only answer is going to be massive amounts of AI and the productivity gains that you get from integrating language models into the imaging models that have already been on the market.
Well, Pelu, it's been a fantastic conversation. I've really enjoyed it. There's one question which I generally ask my guests at the end, and that is if you could pick out one example of medical AI, nothing to do with your own, what would that be?
It's tough for me to say nothing to do with my own because as a platform, we kind of look at and support all AI models, right? We've kind of recently announced and been building out our foundation model LLM offering on the marketplace. So it's unfortunately, I would love to say DeepSeek's open source model because that is the thing that's top of mind, and I think it's going to transform the industry. But if I were to have to pick one AI solution that I think is just really, really, really cool, I would have to point towards the growing number of foundational X-ray models. So, Google's releasing one. I think Annalise is releasing another. There are a few others out there, but I think X-ray is going to be the first imaging type that ends up getting fully automated reporting and kind of preliminary reads generated. And I think that once that dam breaks and kind of once you have x-rays being automatically read with radiologists reviewing them, I think that's kind of the first domino to fall in terms of the much broader acceleration of radiology AI. I just think it's going to take a while because it's just so fundamentally different from how patient care has been regulated historically. So we're very much in the automated self-driving car era, and we're very much trying to figure out, hey, how exactly do we do this in a way that complies with regulations, and regulations are going to have to change. But the benefit is, listen, like no one really wants to read x-rays. They're not reimbursing. Most practices and systems lose money on them, and there are a ton of them. So it's a great place for us to start in terms of the path towards, full automation. But I think that's happening now as you see these x-ray foundation models that can look at 120, 150, 200 different findings.
Okay, so the reason you think it will be X-ray rather than MRI or ultrasound is because of this gigantic superfluity of X-ray images, correct?
Yeah, totally, and the low reimbursement and the fact that they are it's a much easier domain to have very large coverage because there's just so much more data and it's smaller files that can be trained on faster and many, many reasons. But all those combined, I think X-ray is going to be an area of a lot of foundation imaging model work that's going to be pretty crazy to see pretty soon.
And I've got to ask you, I asked you for one example, your favorite one. You've given me like two or three. Let me ask you one last question. DeepSeek, have you tried it out for yourself yet?
I have. I will say it's not the OpenAI killer that people claim it to be. I mean, it's. I think people, you're realizing it was probably trained on these models, and so it's kind of like, building on the shoulders of giants. But I think the more important part is that it requires very little compute, and it was built very cheaply off of those shoulders of giants. And so I think you're going to see a lot more open source models that can be deployed within modest compute environments, which I think means that they're going to be able to be used within hospitals pretty easily. So I played around with it. It's fantastic at explaining itself, which is the really cool thing that I think differentiates it in terms of how it was trained. I recommend you try it out too and download the app. But I personally think that the exciting models are the ones that are going to use the DeepSeek innovations, but retrain them for healthcare use cases. Because again, unlike OpenAI, unlike Anthropic, the model itself is open source, and the way they built it, they've published and made open source. So I think that's much more exciting is the open source nature of what they've done.
Right. I mean, I guess the story is not going to just be about DeepSeek, but about a huge explosion in cheap LLMs in general. Do you think that's true?
Exactly. Yeah. And I think there are going to be a lot of companies built that are going to be just as good and a fraction of the cost of the ones that are out there now. And so, if I were a vendor that's building on top of OpenAI or ChatGPT or Anthropic Claude, I would very much be thinking, okay, like my price point's going to drop. I'm going to have to think about competitors emerging using these solutions that are more specialized, and I'm going to have to actually rapidly respond to that. And I know investors in the venture community are just as much panicking too for their portfolio companies to make this move.
That's what we like, a bit of drama, isn't it?
Totally.
Pelu, I've really enjoyed the conversation. It's been absolutely fascinating. Thank you so much for coming on.
Likewise. Thanks, Felix, for having me.
Speak to you again. Thanks for listening. Ping me on LinkedIn if you have any ideas on new subjects or guests.